getting in some practice here with everything we've covered with integrals. And the first page without calculator, please. So in number 1, we have a horizontal line or constant function from 2 to 7. So you need not draw this, but we're finding the area of a rectangle with a height of 4 and a width of 5. And in 2, we're reversing the limits, so we're going from right to left. So when we go from right to left, the base would not be 5, but negative 5. So that geometrically explains why. We should come up with a negative 20. Question 3, our line is below the axis, but we're measuring 2 to 7 in the positive direction, so our base would be positive 5, but our height would be negative 5. Oops, try that again. Negative 4. So our area would be negative 20. And in number 4, same problem, but this time we're measuring our interval from right to left. So this time our base would be negative 5 and our height would be negative 4. So reversing the negative 20 from question 3 is a simple way of thinking of that as well. All right, so we're given some values here. Integral from a to b is w. Integral from b to c is z. And c is somewhere in the interval, closed interval from a to b. All right, so we're using our properties of integrals here. If we go from a to c and then c to b, of course, that's the same as going from a to b, assuming there's no discontinuities. And here we're going from a to b and then a to c. Well, we would like to have this pick up where we left off. So how do we do that? We want a to be in the middle position. So if I want to reverse these and go from b to a, then I can just put an opposite sign in front. So that would be one way of reworking this so that it fits our properties. And then we can factor a negative out of both of them, factor a negative 1 out of our answer, and then it would be the interval from b to c, so the opposite of the interval from b to c. And you could you could probably do these sometimes in more than one direction. All right, in c, we're reminded of our property that we can factor the 7 out of the integral, and we were told the integral from a to b. So let's also swap our limits. So it goes from a to b. So then we would end up with a negative. So if we swap the limits, then our answer will be negative of what was given. So we were given that this value was w. So we would come up with negative 7w, or the opposite of 7w. If we go from a to a, we get 0 for the integral. Cosine from negative pi over 2 to positive pi over 2. The point here is don't repeat work that you've already done. And the sine function from negative pi over 4 to positive pi over 4. Remember that sine is an odd function. So since sine is an odd function, cosine, by the way, is an even function. Sine is an odd function, so from negative pi over 4 to pi over 4, and you need not draw these diagrams. I'm just adding that as explanation. So we get 0. 1 over x, we have to recognize 1 over x as the derivative of natural log of x. So our antiderivative evaluated from 1 to e squared. So we have the natural log of e squared. Remember, you could bring that 2 over there if you wish, minus the natural log of 1. So natural log of e is 1, so this would be 2 times 1. And natural log of 1, any logarithm of 1, is 0. So we'll come up with 2 there. If we bring this 3 out of this integral, then it's going to look familiar to us. So a bit of a trick here. Now doesn't this look like the integral that we recognize as arcsine. So factoring that 3 out of the numerator makes all the difference. So arcsine, or sine with the -1 exponent, makes no difference. It's an indefinite integral, so don't forget to add the c. Back to a definite integral, but I know secant squared has an antiderivative of tangent from pi over 4 to pi. The tangent of pi, so thinking of your unit circle, here we're at -1, 0. Tangent is y over x, so the tangent of pi is 0, and the tangent of pi over 4, that's our 45, 45, is 1. So we should come up with -1. And I recognize this almost as the derivative of cosecant, but it should have a negative. So to compensate for that, we're going to put negative cosecant of x. Check your derivative. Would you get back to positive cosecant cotangent? And we evaluate from pi over 6 to 5/6 pi. So this negative, don't forget that negative sign. You might handle that by putting it out in front of your evaluation here. Just don't forget about it later if you do that. So we want cosecant of 5/6 pi minus cosecant of pi over 6. Quite frankly, I never do a cosecant. I know this is the reciprocal of sine, so I am thinking of the sine of 5/6 pi is +1/2, so its reciprocal would be +2, and the sine at 1/6 pi is also 1/2, so its reciprocal is 2. So the opposite of 0, I guess, is 0. All right, moving on. Checking your understanding here, notice that this is a Riemann sum. F of x is the height of each rectangle. Delta x is the base or width of each rectangle. We're adding up n rectangles, but the limit operator takes the number of rectangles to infinity. So this is the exact definition. An infinite Riemann sum becomes the exact area, and that is found by the integral from a to b. So that is the definition of integral. We want to keep repeating that, so whenever you're doing integrals, you realize that it's tied to doing the area of Riemann rectangles. All right, so if we're given, for some unknown function, we're given the integral over the interval from -2 to 10, the average height. So regardless of whether that goes from positives to negatives, regardless of what that function looks like, the average height would be found by taking the integral area and dividing it by the entire width, the b minus a. So our average height, so f average, is 1 over b minus a times our integral. So that is a formula for average height, but remember it just says take the area and divide by the base to get the average height as a rectangle. So for example, in the one that I drew, the average height might be something like this height right here, so that we could fill in and turn this into a perfect rectangle. All right, so what are we doing in this problem? We're given the area of 36, and we simply need to divide it by the distance or the width of our interval, which is 12. So here our f average would be 36 over 12, or an average height of 3. All right, the diagram here is completely hypothetical. We do not know what f of x is. Question 9 says find the value of z. Usually we use c for the mean value theorem for this integral. So remember, what we want to do is find the place where the average height occurs. So this is the x coordinate where f average occurs. So You can do this mean value problem step by step, or you can say, where is f of c equal to the average height? And the average height is simply taking the area, that's the integral, take the area and divide it by the width, and that gives you your average height. And now we want to say what value of c produces that average height. So you could do it in separate steps. Here it's all in one step. So f of c would be 6c. Oops, sorry, I didn't want c here. Question asks us to use z. All right, and the width of our interval goes from 0 to 2. And the integral, so let's do this. Antiderivative here, raise the exponent to 2, divide by it, evaluate from 0 to 2. So picking up over here, we want 6z to be equal to 1/2 of, put in your upper limit, that would be 3 times 4. Put in your lower limit, of course, that would be 0. So where is 6z equal to 6? That would be at z equals 1. And check to see, is it inside your interval? Z is an element of our interval. So I think that would work out fine. Okay. For an increasing function, if we do a Riemann sum with right-hand rectangles, what do we know? If we do, and you can draw any increasing function, concave up or concave down, and you'll see that right-hand rectangles are too high, so they produce an overestimate. I would never bother to try to remember those, because you've got every combination of increasing and decreasing, right hand and left hand, easier to just visualize it. On this page, we want to practice using your TI-89 is the point here. So you can find sigma from the calc menu, and sigma requires 4 arguments, your expression, and instead of k, you can use k, you just have to use the alpha key. So you might say, well, why don't I just switch to the x so I don't have to use the alpha key? So each term is x cubed or k cubed, and your independent variable, and then your lower subscript and your upper subscript. So you could plug this into your calculator. And I think my calculations are accurate. 14400. All right, what formula could you use? Remember, the sum of cubes happens to be the same as the formula that Gauss came up with as a child for the sum of the first n integers. So n over 2 times n plus 1, but the sum of cubes is the square of the sum of the first powers. So the first 15 perfect cubes, we can check out this formula, which for calculus purposes you do not have to have this memorized, but it's interesting. So 15 times 8, and then square it, and it should check out to be exactly the same as when you did the sigma method. So it is not essential that you memorize that formula, but I hope it's of interest to you. All right, so this problem would not be, of course, this would only be in a calculator section. It would not be on a quiz unless you were allowed to use your calculator. So this is really just, do you remember how to do integrals on your calculator? And of course, order of operations is the tricky part here. You can either put this as y1 in your y editor, or you can put it right in your home screen, but make sure that you do order of operations. So put parentheses there. Our independent variable is x, our lower limit is 3.5, and our upper limit is 7.1. So make sure you have the correct number of parentheses there. And I think I came up with approximately 0.263, approximate. So to calculate a definite integral on your calculator, and we rarely do this, you just don't put limits. It's exactly what you think it would be. So our expression, x to the 7th plus 1 divided by x, is our expression. comma x with no limits. And you have your TI-89 is a computer algebra system, so it will do that algebra for you. But it gives you the simplest answer. So you have to remember a little bit here that your calculator is only going to give you one antiderivative, and you know that there's a whole family of antiderivatives, so you have to be smarter than your calculator. So remember to add the constant of integration. All right, and review of L4 here. If we're going from 2 to 10, think of your interval from 2 to 10. If you divide that up 4 ways, of course, our delta x, our formula is b minus a over n, but you don't need to memorize that. If you have an interval that's 8 units wide and you chop it up 4 ways, don't you know that your delta x is going to be 2? So these are going to be the divisions. Generally 6 comes before 8. And we're measuring at the left-hand side, so our rectangles are going to be the heights of our function on the left-hand side. So our delta x is the width of all of our rectangles, and then we're going to have f of 2, f of 4, f of 6, and f of 8, and you can put that in your calculator using y1 of 2 plus y1 of 4, or you could do a sigma from 1 to 4, and then your terms would be y1 of 2x. So you're always welcome to change that to sigma notation if you wish, but do the work on your calculator, and I have approximately 4787202.083. All right, and the absolute value of x cubed. A couple of choices here. If there was no absolute value, you know that x cubed is an odd function, so you might first be tempted to say, oh, from negative to positive, that area has to be 0. But once you do absolute value, remember that absolute value would tip both sides up. What used to be negative would now be positive when you do an absolute value. So you could either enter this the way it's given, or you could be smart and say, oh, that's the same as if I go from 0 to 7.56 and double it. So there's always more than one way that you could enter that problem, or you could do absolute value. Remember on your calculator that absolute value is ABS of x cubed, independent variable x, and then you could do this all in one swipe. Oops, I reversed 2 digits there. 7.56 to positive 7.56, and we come up with approximately 15, no, that's the problem number, 1633.2, oops, back to my page, hold on a second. All right, sorry, I don't know how I change pages occasionally. We're back to our approximate answer here, 1633.267. Okay, let me know if you have trouble using your calculator. You want to practice so many times that during a test or quiz you don't have to stop to think how to use your calculator.